Hello everybody. In the previous lecture we studied thermal radiation, and from that lecture we know that the emission of radiation is made by portion or by quanta. In this lecture we will see that the absorption of radiation is made by portion as well. The first effect which we will study is a so-called photoelectric effect. Photoelectric effect. Photoelectric effect consists in emission of electrons from the surface of metal when the surface is illuminated with light. To observe photoelectric effect, we can use such a simple facility as a glass bulb which is evacuated. So there is vacuum, here is one electrode, here is another electrode, this electrode is cathode, this is anode, and we will apply some voltage between cathode and anode, here to cathode minus, anode plus. To measure current we will include here ampermeter in the circuit, and the voltage will be measured with a voltmeter. This battery will be alternative, so in a sense that we will change the voltage which we can apply between cathode and anode. And in this case, to obtain current, we will illuminate cathode with light. We will illuminate a cathode with light. In this case, there will be electrons knocked out from the cathode surface, and these electrons will be accelerated by the field, electric field between cathode and anode, because their electrons are negative, so they will go to positive electrode, and they will reach this electrode and create some current in the circuit which can be measured. There are three features of photo effect which are called photo effects laws. The first of these laws, all these laws were established experimentally, and the first is that the current which is here is not so photo effect, not current. Photo effect is limited in a sense by the frequency of light which illuminates cathode. What I mean, if we measure current here in this circuit and will illuminate cathode with light of different wavelengths or frequency and measure current, then for given intensity of light and given voltage here, we will obtain a graph like this. What is interesting in this graph, that there is a threshold frequency and the photo effect does not exist at lower frequencies. Whatever be the intensity of light, we can increase the intensity of light, but if the frequency of light is lower than this omega threshold, then electrons will not appear here near cathode, and so current will be absent. This is the first. The second is that electrons they leave the surface with some energy, and this energy which they leave a cathode is in the interval from 0 to some maximum kinetic energy 1 or 2 MeV maximum squared. So the point is that there are these energies are different, and this energy does not depend on the density of the flux of light, and linearly depends on frequency. What I mean, how can we measure this maximum energy? Let's apply this voltage in opposite direction. So if we said that electrons leave the surface here with some energy, kinetic energy, which is non-zero, so even if this potential difference of potential will be zero, electrons anyway will go, because they have initial energy, they can produce some current in the circuit, because they can to cover this distance and such close this circuit and create a current in this. In the case we wish to stop this current, we need to apply this voltage in a different direction. So if we apply minus from this side and plus from that side, we will create a retarding field which will stop electrons, provided that this potential multiplied by charge of electron will be equal to this maximum energy. So we can equate this maximum energy to potential energy of electron in this field. So if you remember, U is difference of potential, so E multiplied by this is energy, potential energy of electron. So it cannot reach this anode if kinetic energy is less than this retarding field. Of course, this retarding field is now negative, so if we make a graph again, here is retarding U, this absolute value, because we change it, it is minus. So here is frequency, and we see that this maximum energy linearly increases with omega. Now let's consider what will, this is the second law of photoelectric effect, and the third is a dependence of current on intensity of light. Now we will measure, in this system, we will measure dependence of current on applied voltage between cathode and anode. As far as kinetic energy exists, even some energy, electron possess some energy, even if we don't apply any field, so some current will be observed even at negative U. Remember that to stop electrons we need some retarding field. So this retarding field is here. This is if this is, we will denote retarding field as UR. So this is UR retarding. So the current will increase and very soon it will be saturated. So this corresponds to intensity of light of S1. If we increase intensity of light, of course, we remember that it doesn't, UR retarding will be the same, but saturation will be reached at higher level. This is S2, and S2 is larger than S1. The question arises how we can understand qualitatively why current reaches this saturation level. It's easy to understand that saturation is reached where all the electrons which were emitted under illumination of light reach anode. If all the electrons which were knocked out from the surface reach anode, there is no way to increase current. If this voltage is small, then not all the electrons reach anode. Some of them may be lost on this way, and not all of them. Moreover, the point is that energy is in a wide interval, and if this electron is of maximum energy, so it can reach anode. But if it is of low energy, closer in this interval, so it cannot reach anode until some additional U is applied in order to move this electron to anode. So now we understand why saturation is reached, and this slope is due to wide energy interval of electrons which are emitted. It is again explainable how we obtain different electrons. Imagine that we have a surface, and if electron, okay, here is a surface, and if electron which is emitted is located at very surface, so it obtains when it is illuminated with light, it is knocked out and have maximum energy. But imagine that this electron is somewhere in deep, and in this case it can lose some energy until in this way, and when it goes out, it has energy which is lower than electron as compared with electron which was located at the surface between being emitted. So we can say that in this both cases we have fixed omega, and the third law of photoelectric effect consists in the statement that at a fixed frequency, the number of electrons which are emitted in unit time proportional to the intensity of surface light. From the classical point of view, photoelectric effect can be explained. The problem is with this loss of photoelectric effect. How can we understand existence of photoelectric effect in frameworks of classical approach? In this case, we can say, okay, here is some electron, and here is light. Light has electric field, and this electric field, we remember that intensity is proportional to the E squared. So the greater is intensity, the greater is amplitude of oscillations in light. Then if we see that this field, electric field of electromagnetic wave reach this point, this electron start to oscillate with this field, and the greater is intensity, the greater is amplitude of these oscillations. So it is a safe assumption that in this case electron has to possess more energy because the oscillations of greater amplitude. In classical physics we understand that the greater is amplitude of oscillation, the greater is energy of these oscillations. But we don't observe this, that because we know that energy of these electrons does not depend on the intensity. Only number of electrons which are emitted depends on intensity, not energy. How we know that energy does not depend? We see that in this graph here we have S constant and U constant, and whatever is intensity of light, nevertheless the energy, the retarding voltage is here. So the intensity of light does not change the retarding voltage. Here you see again, for both cases retarding voltage is the same. This is experimental fact. The other point which cannot be explained in which is this contradicts our understanding in classical theory of electromagnetism. Next, the question is how to explain existence of this threshold frequency. From the point of view of classical physics, there is no reason to have this omega threshold, because this oscillator does not depend on frequency. Energy does not depend on frequency, so it is not cannot be explained in the frameworks of classical theory. It was great scientist Einstein who suggested the idea that not only emission of electromagnetic waves is made by portion, as was shown by Planck, but absorption is also made by portion, and these portions are those which are suggested were suggested by Planck. So by E equal to h omega. Then Einstein wrote an equation which is called Einstein equation for photoelectric effect, and this equation is as follows: h omega is equal to A plus kinetic energy of electron. Now let's look at this equation. So the idea is that light is propagated as a flow of particles. These particles are called photons, and each photon bears this energy, and when it interacts with electron, it transfers its energy h omega to electron, and electron spends this energy to leave the surface. Actually, all electrons are somehow bound in surface, otherwise they will be emitted without any external force. And now we need something to remove electron from surface into vacuum, and this is work function A, which is different for different materials. It depends on sort of material, of metal. And the rest of energy is supplied to electron in the form of kinetic energy. If you remember, when we started with optics, we formulated duality of light. We said that light, in some experiments, we observe wave properties of light, and sometimes we cannot explain what is happening with this concept, and we need to consider the light as a flow of particles, and this is such a case. This equation, it explains all three laws which we just mentioned. Laws were derived, again, laws were derived from experiment. Look, for example, if we consider this case with omega threshold, this is energy which is needed to release electron, plus to supply him some kinetic energy to this electron. But in the case that H omega is less than A, is smaller than A, so electron cannot be released, and whatever will be intensity of light in this sense means number of photons, number of this H omega. And if you imagine that there are a flow of these particles, but each of the particle can individually interact with electron, not all of them simultaneously, and each of the particles have only one portion of energy which can be used to release electron and to supply some kinetic energy. So if it is not enough, this energy is smaller than A, so we observe this stop of photoelectric effect. For this, we see that this kinetic energy is proportional to energy of single photon. The greater is energy, frequency, so greater is energy of photon. We remember that E is H omega. So this A depends only on material. So it is constant for given surface, of given material. So the greater is energy of photon, the greater is kinetic energy of electron which is released, because some constant fraction of this energy is spent to release it, and all the other energy is supplied to electron in a form of kinetic energy of this electron. And the third of the laws means that the saturation of current is reached for different intensity at different levels. The greater is intensity, the greater is current, saturation current. It is explained just by assuming that it is simply the consequence of number of photons. The greater is intensity means that number of photons which reach the surface in a unit time is greater, so greater number of electrons is knocked out from the surface, and the number of electrons which cross this distance in unit time is current. You remember dq over dt is current, so the current depends on intensity. This effect is one of the significant indication that light is absorbed by portions, and now we will consider other features of photons. Now, if we obtain energy of one photon as E is h omega, this photon must have also as a particle, if we consider it as a particle, it should have also momentum p, and we will now derive what is this momentum. We will start with known relation for E is mc squared, which is universal equation which follows from the theory of relativity, with this relation between mass and energy. And we can rewrite it as mc multiplied by c. This is this part, and E will substitute h omega, so it is h omega. But mass and multiplied by speed is momentum. So on the other hand, omega divided by c is k, a wave number. So we have that momentum is hk. K vector is normal to the wavefront, so it is directed in the direction in which a wave propagates. Then, of course, photons move in the same direction as the wave propagates. In that case, we can write this equation also for vectors. So we can write that P is hk. So this is the equation which show us that momentum of photon can be expressed through the wave vector. The question is, how can we prove that photon has momentum? This is evident that this assumption or this result is correct when we consider Compton effect. What is Compton effect? Compton investigated scattering of X-rays on different materials. Experiment was like this. Photons were scattered on piece of material, and this was X-ray photons. The result of scattering was measured at some angle relative to the direction of primary beam, and at this angle theta. The result was that in addition to the energy or wavelengths of X-rays, which were in initial ray, and these rays were monochromatic, in the scattered rays there were additional wavelengths which was greater than the wavelengths of the primary beam, and in plot it looks like here shown here. So if this is wavelength and this is intensity of waves, so there was, and this point is lambda 0, not 0, but lambda 0, this is. So it was observed, this line, due to energy resolution it was not sharp but spreaded. But there was also additional wavelength in the scattered radiation, and this lambda prime, difference between lambda 0 and lambda prime was delta lambda. From experiment it was found that delta lambda measured in meters is 0.048 10 minus 10 sine squared theta over 2 meters. This experiment was done with different materials and with different wavelengths, and it appeared that this delta lambda doesn't depend on the primary lambda 0 or on the substance which is used. Then it was suggested that the observed result is due to scattering of photons on single electrons and free electrons which are available in this piece of substance. And if we consider this from the point of view of classical scattering, classical mechanical laws, and this laws means that always momentum and energy should obey conservation laws. In our case, if we look at the momentum diagram for this scattering, we have here is electron in initial position and he in rest. Here is this photon which propagates this way, and its momentum is hk. Momentum of electron in the initial stage of scattering is 0. Then the momentum of scattered X-ray photon is hk prime, and after scattering some energy and momentum is transferred to electron, and electron is recoiled, and now its momentum is mv, where m is mass of electron and v is velocity of electron. This is angle theta. For this diagram we can write down the following equation. hk, this is vector equation, is hk prime plus mv. This is momentum before scattering, this is a momentum after scattering. M is mass of electron, v is velocity of electron. Energy also should conserve, and h omega is energy of photon before scattering, and electron before scattering had energy m0 c squared, whereas m0 is energy when electron is in rest, and from E is m0 c squared. And after scattering we have, here is energy h omega prime is energy of scattered photon, and electron has energy mv, where m is relative mass is mass of from the relativity theory, mass, relativistic mass m is m0 divided by square root of 1 minus v squared over c squared. Or we can rewrite it as m squared 1 minus v squared over c squared is equal to m0 squared c squared. Finally, we can rewrite it as m c squared minus v squared is equal to m0 squared c squared. Sorry, here was no c squared, of course, we just m0 squared. Okay, now it is correct. Well, using these equations, we will transform them to and then compare with this result. So we will derive left part from this. To do this, first we will remember that omega over c is k. So we will take the second equation and divide left and right parts of this equation by c. Then we can rewrite it in a form that h k plus m0 c is equal to h k prime plus mc, or mc is m0 c plus h k minus k prime. Now, to obtain this term, we will square this equation, and left part is mc squared, and right part is m0 c squared plus h squared k minus k prime squared, and plus 2 m0 c h k minus k prime. Now we can open this parenthesis, and then mc squared is m0 c squared plus h squared k squared minus 2h squared k prime plus h squared k prime squared, and plus 2 m0 c h k minus k prime. On the other hand, if we take the first equation, then for this equation we can obtain the following. We will transfer this term left part, then mv squared. Our aim is to obtain the second term as mv squared. So we have already obtained mc squared. Now we will, from another equation, we will obtain this one. So when we square this equation, we have mv squared is h k squared plus h k prime squared and minus 2h squared k prime cosine theta. Look, this equation is vector equation. So when we squared k minus k prime, and we have k squared, k prime squared, and here we have scalar product of k and k prime, so we have this cosine theta. Now we'll rewrite this to equation. We will look this. We wish to obtain something like that. So, in order to do this, we write m squared c squared minus v squared is m0 c squared minus 2h squared k prime, and here is 1 minus cosine theta plus 2 m0 s c h k minus k prime. We took into account that, look, when we obtained from this two equations this equation, there was a h k square here and h square k square here. Here the same h k prime, here h squared k prime, so they cancelled, and remaining terms are here. Now, if we compare this and this equation, so we see that this left part is equal to m0 squared c squared. So this left part is equal to this. So right part is equal to this also. Then we can cancel this and this m0 c squared. And then we have that this term is equal to this term, because all this is equal to, okay, let's rewrite it. Then we see that m0 c squared minus 2h squared k prime 1 minus cosine theta plus 2 m0 ch k minus k prime is equal to, this is equal to m0 squared c squared. So this and that is cancelled. And finally, we have that m0 c k minus k prime is equal to h k prime 1 minus cosine theta. 1 minus cosine theta is 2 sine squared theta over 2. Now we will divide left and right part by k prime m0 c and multiply it by 2 pi. So left and right part are multiplied by such factor. This will give us that 2 pi over k prime minus 2 pi over k is 2 pi h over m0 c 2 sine squared theta over 2. What we have here, we have actually delta lambda. This is lambda prime, this is lambda 0 initial energy wavelengths of initial wave. So we see that delta lambda, which we derived from conservation law, is 2, this is 2 pi h over m0 c sine squared theta over 2. This term has a dimension of wavelengths and is called Compton wavelengths. Then if we compare this result with experimentally obtained result, we see that this number actually is 2 lambda c. So this number is equal to lambda Compton. Look here, all the members of this term are known, H, M0, C, so we can compare what we have theoretically and experimentally, and the agreement is good. Thus, we can say that Compton effect proves that indeed each photon has a momentum, and this momentum is P is hk. Now we will try to formulate how we understand what is a photon. It is not so easy to make a strict definition what is photon, because you see that the photon is, due to duality of photon, it is a wave and it is a particle simultaneously. So we formulate it that photon is a physical object which is related to electromagnetic radiation, and which in any interaction of radiation with a substance acts always as a whole, which is characterized by energy E equal to h omega and momentum as P is equal to hk. It should be also mentioned that the photon has no mass of rest. He exists always in a movement with a speed of light.